Okay, Year 10, it's the 1.3 booklet, Making Use of Energy. Obviously write your name, form, set and teacher in there. One of the equations that we're going to be using this time round is this one here. Density is mass divided by volume. It's given this symbol here, P equals M over V. The P stands for density. And there it is again for the foundations. If we have a read through this, electricity is produced by a generator. A large magnet spins inside a coil of wire, generating a current. In a fossil fueled power station, the generator is spun by a turbine which is driven by high pressure steam. The steam produced from water heated by the thermal energy, the heat released when fossil fuel is burnt. Any moving fluid, and that could be a liquid or a gas, will spin a turbine. So running water and wind can be just as effective as steam at spinning the turbine. In fact, we have been using running water and the wind for centuries to provide us with energy. Look at the diagrams here of the water wheel and the windmill. You could have a read through this paragraph here, and then the question is asked, what two characteristics in a fluid, like water or air, determine the amount of kinetic energy that the fluid possesses? Well, the amount of kinetic energy that the fluid possesses will be as a result of the speed of the particles and also the amount of particles flowing through. In other words, the density of the fluid. Now then, how much mass a substance has in a given volume is called its density. So the units for volume could be centimeters cubed or milliliters, and the units for mass could be grams or kilograms. Okay, question 1 and question 2. Does air have volume? And question 2, does air have mass? I'm going to pause the document for a second. Write down yes or no for both of those questions. Of course air has volume, and of course air has mass. Now we've got 4 substances. For question 3, put the following substances into their order of density, the most dense being first. This is how you would work this out experimentally. Okay, this is the first video from Year 10 1.3 booklet. How much mass a substance has in a given volume is called its density. Now we have here 4 different substances. We've got methylated spirits, a type of alcohol. We've got oil. We've got water that has been coloured, and we've got air as well. Now, your job is to, on question 3, is to put the following substances in their order of density, the most dense first. That's the heaviest. Okay, so if you write down your 4 answers now, the densest first, the least dense last. I'm going to pause the video for a second for you to write down your answers. Now let's see what the actual answer is. So I'm going to pour in some oil into the measuring cylinder. There's the oil. Followed by the coloured water. Now I'm going to tip the measuring cylinder slightly. Pour in this coloured water. Let's see what happens. And you can see there that the coloured water has sunk to the bottom. So it's obviously denser than the oil. Finally, we'll put in the methylated spirits, methanol, type of alcohol. In it is poured. And so, let's have a look at the result here. The least dense, air. Slightly more dense, methanol. Even more dense, oil. And the densest substance here, coloured water. Coloured water has the most mass per given unit volume. It's the densest one here. 0.3 booklet. Here we're going to be measuring the density of air. Here we're going to be measuring the density of air. Now, in order to do that, we're going to be using a balloon. This is an empty balloon. I place this holder on top. That will stop the inflated balloon from rolling off. You'll see that in a second. I now have to zero the mass scales. And now we measure the mass of the deflated empty balloon. 2.68 grams. It's decided to go up. It's 2.69 grams. Now, remove the balloon. Blow it up slightly. Put it back on the scales. And we should find that the mass of the inflated balloon has gone up. It is now 2.73 grams. 2.73 grams. If we take those two values away, 2.73 take away 2.69, we end up with the mass of the air, which is 0.04 grams. to work out the density, we do need the mass. We've got that of the air already, 0.04 grams. But we also need the volume of the air. So, in order to work out the density of the air in the balloon, we've got the mass already. We just need the volume of the balloon. How do we work out the volume? Well, we've got some water here, we've got a tank of water, and if you notice, the water line here has got a black mark. It's right there. Like so, there it is. And I'm going to put the balloon into the water, and the water level is going to rise. Here we go. The balloon is going in. We're going to cause the balloon to move, submerged totally under the water, hopefully. It won't be perfect. No, it won't be perfect. Okay, that'll have to do, right? So, what I've got to do now is measure the increase in the water level. Forgive my fingertips in the water, but hey ho. So, the water level has gone up. It's gone up to here. That's the new water level here. I can now remove the balloon. We will get an approximate volume for the balloon. And the way that we work out the volume of the air in the balloon is we take the length of the water tank, 44 centimetres. We multiply that by the width of the water tank, 29 centimetres. And then we multiply that by the height of the water. I'm just going to get in here now. Apologies, I'm going to get in the way of the camera, but only for a second. And that that length is exactly 1 centimetre. 1 centimetre. So the volume of the balloon is going to be 44, the length, multiplied by 29, the width, multiplied by the height that the water rose to, that's 1 centimetre, and that gives us 1,276 centimetres cubed. Using that information and the mass of the air, we can calculate the density of the air.
Okay, let's put those results in to work out the density of the air. The mass of the deflated balloon, 2.69 grams. The mass of the inflated balloon, 2.73 grams. The mass of the air, take one away from the other, 0.04 grams. The volume of the inflated balloon was 1,276 centimetres cubed. And so the density of the air, write the equation down, then put the workings, the mass, 0.04, divided by the volume, 1,276, and that gives us, I put that into the calculator and it gives me 3.1 times 10 to the minus 5, and here are the units. It is the number of grams per centimetres cubed, or as a decimal that would be 10 to the minus 1, 10 to the minus 2, 10 to the minus 3, 10 to the minus 4, 10 to the minus 5 gives us 3.1. So it's 0.00031 grams of air per centimetres cubed of air. That is the end of lesson 1.